Hello there once again. Welcome back to the never-ending saga of who's who and what's what and what the heck's going on with the security stuff. I thought they had me once again, and I was just about ready to give up when I realized. See now, remember. Log on session, prove beyond any shadow of any doubt that processes in, whatever in is, it means something. A log on session have the same primary access token. Right? Now that showed that demonstrated that not all of the processes that we were seeing were in the same logon session. 1, 2, logon SID. Now that's that FACO this thing. The last number. That's called the logon SID. They even tell you how to get it. See? Okay? That's how I'm getting it. I use token groups and I find the one that's got the logon SID. Now, the logon SID is valid, blah 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 blah. Logon SID is unique. No other logon sessions will have the same logon SID. That may be true. However, the set of blah 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 blah. Now, this here, session 955, has listed in its access token that same logon SID. Pardon me for a minute. Yes, as I was saying, yeah, that in no way implies that it is in this logon session, the one identified by this number. That does not say that. Right? This doesn't say that. All it says is that logon session has been identified in the access token. That's it. It doesn't mean that it's in that session. It's logon session, the logon session of this process is can be identified, even though we may not know what the actual session number is, or even for this, is identified by this number. Now you might think that I'm just they call it picking at, little nitty-gritty details. Have a look at this session if you think that I'm talking about nothing in particular. I need a little batch file called invite, which can invite some of our friends into our little world, our happy world. I'll put low standards because I remember his or her password. Hello, low standards. Welcome to our happy world. Whoops. Now let's have a look at low standards. Logon ID. Well, this part certainly looks a little bit like that, a bit bigger. Ooh, look, same logon ID. Terminal services 3. Yeah. Well, there's only 3 around. I can tell you that much. I mean, there's only 0 and 3 around. Okay. Now, this is sorting by time, it turns out, I think. Yeah. Okay, whatever. Don't know why those are there. But have a look at that middle number. Okay. You think it's probably a bug, but it is not. Well, it could be a bug, but I don't think so. Those standards here, having been run as in order to get in here, has in his or her non-restricted groups. Well, for one thing, the current logon session identifier is identified in here, but that should in no way prejudice one into believing that this is in the logon session, because it doesn't have the same primary access token. It's similar, but you know, the authentication ID is different. Its originating session happens to be my session. Happens to be the session of Little Alan, or Alan Minor. So this one didn't come from 999, this one came from me. It owns itself. Yeah, it doesn't have any restricted groups. Its source name is another source called SecLogo, which I think means security logon, secure logo, and all the rest. You know, what you would expect. Terminal services 3. 904 is the logon SID identified in its token. Doesn't mean it's in it. Okay. Now what about this great big number? I don't know. I think it's probably 2 numbers. You know, it's interesting that these 2 processes are able to communicate either way. Well, at least as far as my favorite program, my favorite new program, Tray, which I should show you how it works. Now it has a special feature where I can specify a window. Let's say 969, which should locate this window. And it did. See? I was able to, this guy, who's, you know, just been a welcome guest, can communicate with this thing. Of course, this guy created this guy. And this one, 131713. This one can make this one go minimized. So there's back and forth communication between these 2. And I believe that the umbrella of security that allows that communication to occur safely is somehow contained within this number, which looks like a pretty randomly generated number to me. It has something to do with keys, session keys and whatnot, encryption keys. Now, okay, goodbye to that guy. Don't know what these guys are doing. Nothing of any good, I'm sure. Okay, everything's fine. I had a weird thing come up in here earlier today. I'm not sure what it was. But anyway, it's gone now. So, okay, I'm okay with that now. So I finally went and just I said, okay, enough's enough. I've got to see a session key. I've got to just see what does it look like. You know, like, can I make one? You know, can I use one? Can I encrypt something or send a message? Like, is there an example? Well, it turns out there are loads of examples in the help file, the hint file. To do with this stuff. But first you gotta get a couple more words under your belt. And I knew that I would have to look at this BLOB, and I hope to hell that is an acronym, because if that's somebody's idea of a joke, and they deserve whatever's coming to them. Okay, BLOB. So this is under cryptographic thingamajiggamies. BLOB. Okay, that's where I didn't even look at all of them yet. A generic sequence of bits that contain one or more fixed length header structures plus context specific data. Well, that's pretty general. So see also key blobs, certificate blobs, certificate name blobs, attribute blobs, etc. So whatever this blob thing is, it's a pretty general thing. Now, one of them has to do with these key things. So I looked at that first. A key blob. It is a blob that is a generic sequence of bits containing, some fixed length thing plus context stuff. A blob containing an encrypted private key. Okay. Key blobs provide a way to store keys outside of the CSP. Now, I got this wrong last time. CSP is Cryptographic Service Provider. Not whatever I had before. Key blobs are created by exporting an existing key from this provider by calling the exporting thing. Export key. So take a minute to think about it. A key blob is a blob containing an encrypted key. An encrypted private key. So now this continues on. So imagine now that you've been using a private key to send maybe a session key to send your messages back and forth, and you want to store that off somewhere safely. So apparently you use a key blob, and it encrypts your key for you. And the way it does that is you call this function, and it gives you the encrypted version of your key. Later on, the blob can be imported into a provider. So first we started with one provider and exported the encrypted key. Now we can import that into another provider, and it says it can be a different cryptographic provider on a different computer even, and we call the import function, and this will create a key in that service provider that is a duplicate of the one that was exported. How that's done is, I don't know. Then it says see these various things. So I went to see simple key blob, a session key encrypted with the key exchange public key. Okay. Now this has to go. We have to jump to K4 before going on. Key exchange. A key exchange, right, is a thing. It's a pair of keys. A key exchange pair, okay, or exchange key pair. These mean the same thing. There are two keys in a key exchange. One public, one private. Okay, so before continuing on, finding out what a key exchange pair is, it's a public/private key pair used to encrypt session keys so that they can be safely stored and exchanged with other users. So if I have a session key and I want to store it on disk, or I want to give it to somebody else, this set of keys enables me to do that. Now they tell you how you're supposed to generate them. And one thing they say to look at is to look at this in comparison with signature key pair, and I didn't look, so I don't know. Essentially, it's this: you got a public and a secret key. Okay. Now the public key part of the key pair is used for encryption of either session keys, messages, and or signatures. And the secret part is used for decryption of the same. Now, more specifically, maybe we should jump back to the other one first. Well, let's see. I wrote this down. So, a key exchange pair only used to encrypt session keys for storage and safe exchange with other users. And those pairs are generated using this. The public element of such a pair belonging to the recipient. So the recipient has one of these pairs, okay, and they've made this part public. So the public element of the pair belonging to the recipient, the destination, is used to encrypt a session key, which is then transmitted to the recipient or stored. The recipient may then decrypt the session key if it is transmitted, and then that single key becomes the session key for further communication. This is my take on it anyway. Now going back to this simple blob, session key encrypted with the key exchange public part of the destination user, right, is called a simple key blob. So you take a session key. Supposing I had a session key in my pocket, I encrypt it with this public part. The public part being of the destination user, they can say user. This key blob type is used when storing a session key or transmitting a session key to another user, just like I said before. Key blob is created by calling the export key. Okay. The pairs are created by calling some kind of a generator function. Okay. And these pairs are called exchange key pairs. To create the blob, one would call this export part, and I don't think I've called that function, but I suppose you pass it in public. The destination is public key, and you're putting your session key. Out comes the blob, which is your encrypted session key, which you send to the destination user. Anybody could intercept the message if they want, but they can't make any sense of what's in the message. Only one person knows how to decrypt that message, and that will give them the one and only one session key, which is what allows the communication between the two members of that communication session. Now, that's to me makes sense. Session as a conversation involving an encrypt and a decrypt key, which has some way of being transmitted using these key exchange pairs. Makes sense. To me, that makes some sense. I started reading some other ones, but I don't think that this is so important. Now, in the help, okay, they got a whole bunch of little snippets of code like that. And I cut a whole bunch of them out, and I put them in this file. I don't need that, but whatever. I got 5 of them in here with a bunch of go-tos. Now, the first test, this lists the available CSPs, cryptographic service providers. And according to my the way my unit test thing here works, if I just put a 1 here, If I put a 1, it's going to go to crypto1 and run unit test 1. So compile it, run it, unit test 1. So here's a list of the cryptographic providers on my computer. Now they have types and they have names. That's the first unit test I found in there. The second test I found in there prints out the type, what those types mean. I also built into my thing that I can have it like keep going on to the next unit test. So this should do the first 2. That did. Okay, so type 1 is RSA full signature and key exchange. See, here's the key exchange using RSA full. 3. A lot of them are 1s. In particular, this last one. You'll notice this Diffie-Hellman key exchange, however you pronounce that, you will note that in that crazy cryptographic extraction derivation key blah 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 document I mentioned last time in the introduction, there's that name in the first paragraph. So that's where that name comes from. RSA we know about. More Diffie-Hellman key exchange. Then we know what key exchange means and something about signatures. One is specific to Outlook for some reason. A little bit frightening. Okay. Now what is unit test 3 doing? Oh, default provider. Okay. Certainly want to know what the default is. Default is this one, strong cryptographic provider, which is which is of type 1, which is RSA encryption full for signatures and key exchange. Okay, so that's of some interest. Now there's more than the ones I have here. Now 4 here didn't seem to work for me. I didn't type something in right. I had to create a container. I think I created a container finally. But if we go to 5, here is supposed to create a this 5, 4, that's 4. Yeah, that's 5. You get a crypto provider. Okay, now here's a handle to a crypto key, public-private key handle. A username optional. No, this username is optional. This will hold the name of the key container. You can see, you can give it a name, and you can also supply optionally a username. Now, it took me a while to realize that I had to look at the comment here, and it says use the default provider. So I did that. Run up here. Now I'm going to acquire a crypto context using the default provider. I've already, I don't know, this is just garbage, right? I don't like to initialize anything. Everything here is garbage. Okay, now see, it succeeded. A crypto context with the Allen key container has been acquired. I'm not sure exactly what that means. That sounds good. Now, we want to get the name of the container. Okay. Succeeded. Notice the 1, 2, 3. Notice this number for this handle. You see how much that looks like these numbers? 1, 2, 3, 4, 2, 5, 2 something, 2, 5, 4. I think these are handles to these crypto thingamajiggamies. But I never prints it out here. You're not supposed to print it out. That's bad. A crypto context has been acquired, and the name of the container is Allen. And I think my crypto context might be a key pair. Possibly. Key exchange pair. Okay. Oh no, now I want to get the key exchange key. So let's see if we can get a handle to a key exchange key. So that'll be that public-private thingamajig. And it worked. It's available, and look. No, where is it? Here, see? Same sorts of numbers, always. But they never printed it out. So it existed or was created. Now if H key just destroys everything instantly, because apparently you don't want to keep these things around for too long. It exists. Oh, now what have I done? Check the exchange key. So what have I got here? Provider, H key. Oh, okay. Another one. Here's the exchange key, I guess. An exchange key pair existed, or did exist, and now it just simply destroys it like it did everything else. Then release context. Everything's okay. A signature key pair and exchange key exist in the Allen container. So I actually have one, and if I wanted to, presumably, I could retrieve it and use it to send if I had a session key, send that session key to someone, and we could have a secret conversation based on that key. Well, some I could publicize the public part of my key exchange key, and someone who wants to send me their session key would use that to encrypt their session number, send me a message, and then I can get a session number from them, and we can have a conversation in private, as it's supposed to be. Now, what does that tell us? Well, for one thing, I bet these are all handles, are all the handles to crypto key thingies. Even though we don't know what the data is, the handle's different. Well, this thing here has perhaps a handle to a key exchange object, and could make public the public part of that. And if something wanted to communicate with this thing, it could encrypt a session key value, of which I've never seen a session key yet, with that, and send it over safely or store it according to the help. Now that's only part of it. Like, for instance, there will be more code here. I guess no. Oh, here. There are all sorts of unit tests that you can run to see how all this stuff works. And I think that the key, to understanding this is to actually go through all of these examples and get a unfortunately have to look a little closer at this encryption stuff to understand what these session keys and everything are, in order to make any further sense of the help. However, I did run across how much time I used. Before I go, I want to just note that online I found something of interest. You know this thing that keeps popping up? Last one. This mandatory label blah 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 thing. And I said this looked like a flag. Well, in fact it is. These are called the integrity levels. And there's a link here, I guess I'll include them in the thing here in the description. Defines integrity levels by using a security identifier to represent an integrity level. Makes it very easy to integrate the mechanism into the security data structures without requiring code changes. Now, if you remember anything about back with the DOS stuff, I was saying that there's a very important message to be learned about this. I was talking about something called abstract data. Well, this is exactly what they're doing. What they're doing is they're taking an existing code and modifying the data in order to make the code that's already there, not changed, implement a mechanism for them that facilitates this integrity stuff. You know, I even had a thing I never showed you. Maybe it's here. Oops. I had prepared a picture that I never had a chance to show, and it was to do with that abstract data versus abstract code. Somewhere in here. No, what was it? Can't be L. Me. Com. It's probably gone. I have a great picture. Oh, maybe I can do a text search. Okay. It's the very final thing that we went through, which used what I call the method of data abstraction. Maybe it's just in my lessons. No. Sometimes these things are hidden. Huh? Come on. Too bad. It's a perfect picture of what was going on there. Anyway, so 16 is the famous number. And the values are 0, 1,000, 2,000, 3,000, or 4,000. 0 being untrusted, low, low integrity, medium, high, and system. I don't know why this. Oh, I just made a mistake. This should say medium, and this should say high. System. I just copied this off their page. Yeah, so my normal self is 2,000, which is medium trust. This one is 1228. So that's a high level of trust. So the operating system trusts this, has faith in this token, and allows it therefore to have more access. So the lower this number is, the less access a process will have. And I guess there's more I can include. In the description. Anyway, those are a few things I found out. And I'll let you think about them. Okay, see you later. Bye. Oh, and sorry. One other thing I forgot, and now I don't remember where I found it. This here document, which I suppose is probably in my history somewhere. Let's see if I can find it. This is where poor little old Microsoft in 1996, it says 95, gets its evaluation from the national security from the Department of Defense on its C2 certification. It's hard to see. We'll zoom in a bit. And this outline, this is written by the Security of Defense, the Department of Defense, I guess, who have outlined this, is in a much nicer format than the help file. I think you could learn it a lot faster by going through this. Part of it has to do with the hardware, what the 8086 is capable of doing. So here's their evaluation process overview. Final report on Windows NT. Now this is 3.51. Well, 3.5 with Service Pack 3. In the end, anyway, if you want to see the answer, whether or not they passed, they did pass. Get past the appendices, comments. I haven't read through all the comments. Windows NT satisfies the C2 design documentation requirement was the conclusion. Well, for this particular bit, but it satisfied everything of interest. Oh, one particular sentence. To do with that auditing stuff. Testing, theory, architecture, audit. I just like this sentence here. Note that Windows NT satisfies the object delegation requirement as interpreted by the audit guideline and not as according to the strict interpretation of the TCSEC, which is some other committee. So it's not strictly following the rules. It's following their rule, national security audit guideline rules. Therefore, Windows NT satisfies the C2 audit requirement. Basically, it also says here that anyone can just go in and delete and make up things as they want. Now, where I found that, I don't know. Here it is. Copy address. So if you're curious and want to see how NT was evaluated by the National Department of Defense, you can read through that. That was 96. It wouldn't be much different today, I don't think.